The western region of the United States harbors a dormant behemoth. Despite intermittent activity, the supervolcano under consideration has remained dormant for an extended period of approximately 70,000 years. However, upon its eventual awakening, it has the potential to emit a resounding roar and exhibit immense strength with unparalleled intensity. The colossal structure referred to here is the supervolcano located beneath Yellowstone National Park.
Underneath Yellowstone, that if it erupts in a maximum eruption called Category 8,
a vast area dedicated to the conservation of wildlife and forests, spanning across the states of Wyoming, Idaho, and Montana. The volcano is situated in the northwestern region of Wyoming, encompassing the majority of the Yellowstone area. The geological formation located above the Yellowstone supervolcano is situated on a geothermal anomaly characterized by the presence of molten and partially molten rock known as magma. The influx of magma into an underground magma chamber, located around 6 to 10 kilometers, 4 to 6 miles, beneath the park, results in the expansion of the surrounding ground. When the process of magma solidification and cooling commences, the ground collapses. According to volcanologists, who have been conducting measurements since 1923, it has been observed that the ground had an elevation increase of around 25 centimeters, 9.8 inches, during the period spanning from 2004 to 2009. Nevertheless, the sinking of the ground began in 2010. The current phase of gradual and consistent increase in activity has prompted some scientists to contemplate the possibility of an imminent eruption occurring in Yellowstone. In the event that an eruption occurs, there is apprehension regarding the potential magnitude of such an eruption. In the event of a substantial eruption of the supervolcano located beneath Yellowstone National Park, there exists the potential for the dispersion of ash over extensive distances across the United States, resulting in catastrophic consequences such as structural damage to buildings, overthrow of agricultural crops, and the cessation of operations in power plants. The possible repercussions would be severe and devastating. However, it is important to note that this does not imply that we should collectively initiate a state of panic. Fortunately, the probability of such an occurrence is relatively low. Throughout history, the Yellowstone supervolcano had just 3 very colossal eruptions, each surpassing the magnitude of a typical volcano by thousands of times. 3 events took place in the past. One event happened approximately 2.1 million years ago, another event occurred around 1.3 million years ago, and the third event took place approximately 664,000 years ago. Contrary to occasional media claims, there is currently no evidence suggesting an imminent occurrence of another super eruption. Indeed, there exists the possibility that Yellowstone may never have another eruption of such magnitude in the future. Nevertheless, the Yellowstone supervolcano continues to captivate the imagination with its potential for cataclysmic events, a phenomenon that can be easily comprehended. A scientific publication was released in September 2014 by a group of researchers, which delved into the examination of the potential appearance of a Yellowstone super eruption. This work was published in the journal Geochemistry, Geophysics, Geosystems. In addition to other findings, it was determined that the volcano possessed the potential to engulf states such as Wyoming, Montana, Idaho, and Colorado under a layer of damaging volcanic ash measuring 3 feet in depth. This ash, composed of fragmented rock and glass particles, would also extend its coverage to the Midwest region. The substantial amount of ash has the possibility to adversely affect vegetation and wildlife, cause structural damage to roofs, and disrupt the functionality of various electrical devices. According to Jacob Lowenstern, a researcher from the U.S. Geological Survey, it is important to note that the report does not make any assertions regarding future events. According to him, in the event of an imminent eruption of Yellowstone, it is unlikely that the most severe outcome will occur. A point that is frequently overlooked in media coverage is the prevalence of tiny eruptions, which are significantly more common. In addition, even these minor volcanic outbursts exhibit a remarkably low frequency. Dr. Lowenstern holds the position of scientist in charge at the Yellowstone Volcano Observatory, located in Menlo Park, California. What is the Yellowstone supervolcano? Beneath Yellowstone National Park is an underground reservoir of highly heated lava, situated at a depth of around 5 miles. This reservoir is supplied by an immense plume of molten rock originating from several hundred miles beneath the Earth's surface. The thermal energy present in the park's geological formations is accountable for the formation and sustenance of numerous renowned geysers and hot springs. As the molten rock ascends into the underground cavity and undergoes solidification, the surface directly above experiences intermittent fluctuations in elevation. Throughout the course of history, there have been rare instances in which the magma chamber has undergone eruptions. The overwhelming majority of volcanic eruptions in Yellowstone National Park have consisted of relatively minor lava flows. The most recent eruption of this nature took place approximately 70,000 years ago at Pitchstone Plateau. However, the primary factor that contributes to the significant focus on Yellowstone is the exceedingly rare potential for catastrophic super-eruptions. A super-eruption is defined as an event that surpasses a magnitude of 8 on the Volcano Explosivity Index, resulting in the expulsion of at least 1,000 cubic kilometers or 240 cubic miles of material. This quantity is sufficient to submerge the state of Texas to a depth of 5 feet. The magnitudes of these super-eruptions surpass those of conventional eruptions by several orders of magnitude. The following figure, sourced from the United States Geological Survey, USGS, presents a comparative analysis of the Yellowstone super-eruptions and the eruption of Mount St. Helens in 1980. The disparity is significant. Super-eruptions versus ordinary eruptions. Yellowstone National Park has seen 3 significant volcanic eruptions during its geological timeline, namely occurring approximately 2.1 million years ago, 1.3 million years ago, and 664,000 years ago. The last eruption, occurring at Yellowstone Lava Creek, resulted in the expulsion of a significant amount of subterranean material, leading to the formation of a depression of approximately 34 miles by 50 miles. This geological feature is now recognized as the Yellowstone caldera. It is important to acknowledge that Yellowstone is not the sole supervolcano in existence. Geologists have discovered indications of a minimum of 47 super-eruptions throughout the course of Earth's geological timeline. The most recent event took place approximately 26,000 years ago in Lake Taupo, located in New Zealand. In a more pronounced manner, the colossal Toba eruption occurred approximately 74,000 years ago as a consequence of tectonic plate movements. The occurrence of the event resulted in a significant and prolonged period of worldwide winter lasting approximately 6 to 10 years, which some scholars argue could have had a catastrophic impact on the early human population, possibly leading to its near extinction. On average, the Earth has seen around 1 super-eruption per 100,000 years. However, this occurrence is not considered a rule of thumb. So what might a Yellowstone eruption look like? It is important to emphasize that the probability of a Yellowstone eruption, whatever of its magnitude, is quite low. However, in the context of a hypothetical scenario, the most probable eruption scenario in Yellowstone entails a relatively minor event characterized by the generation of lava flows, like to the ongoing volcanic activity observed at Barabunga in Iceland. Likewise, there is a potential for a conventional volcanic explosion to occur. The occurrence of a series of seismic events inside a particular area of the park would likely serve as a precursor to the ascent of magma towards the Earth's surface. In the event of an exceptionally large super-eruption, the indicators signaling its occurrence would be significantly magnified. According to Lowenstern, it is probable that the initial manifestation would involve a substantial increase in seismic activity throughout the entirety of the park. The process of breaking down the overlying rock layers above the magma chamber preceding an eruption may span a duration of several weeks or even months. In the event that a super-eruption were to occur, characterized by a magnitude 1,000 times greater than that of a typical volcanic eruption, the expulsion of at least 240 cubic miles of material, and a duration spanning several weeks or months, what would be the implications? The lava flows would be confined to a relatively limited area within the park, around 40 miles in radius. Indeed, it is noteworthy that merely approximately 1/3 of the substance would ultimately ascend into the Earth's atmosphere. The primary source of harm would arise from volcanic ash. which consists of fragmented rock and glass particles, propelled several miles into the atmosphere and dispersed across the nation. In their recent scholarly publication, Lowenstern and his team conducted a comprehensive investigation utilizing historical ash deposits and sophisticated modeling techniques. Their findings indicate that an eruption event would generate an umbrella cloud, exhibiting radial expansion in all directions. The discovery was unexpectedly remarkable. A potential super eruption has the capacity to deposit a significant layer of ash, approximately 3 feet in depth, which might have severe consequences for extensive regions encompassing Wyoming, Idaho, Colorado, Montana, and Utah. In the interim, the Midwest region would experience a modest accumulation of ash measuring a few inches, although the coastal areas on both sides of the country would observe somewhat lesser quantities. The precise distribution would be contingent upon the time frame and prevailing meteorological trends. Any of these scenarios would be highly unfavorable developments. The substantial quantity of volcanic ash possesses the potential to cause fatalities among individuals, adversely impact plant and animal life, as well as result in the destruction of structures. Even a little amount of ash, measuring just a few inches in depth, which is a common occurrence in many regions of the country, has the potential to inflict significant damage to agricultural lands, obstruct transportation routes, give rise to severe respiratory ailments, impede the functioning of sewer systems, and even disrupt the operation of transformers. The cessation of air travel would be required in a significant portion of the North American region. A volcanic explosion of such magnitude would also exert significant impacts on the worldwide climate. Volcanic eruptions have the potential to release sulfur aerosols, which can effectively scatter sunlight and contribute to the cooling of the Earth's temperature. These particular particles exhibit a brief lifespan inside the environment, hence resulting in a transient impact. Nonetheless, this impact can still be characterized by its significant nature. The eruption of Mount Pinatubo in 1991 resulted in a temporary cooling effect on the Earth's climate, causing a decrease in global temperatures by around 1 degrees Celsius, 1.8 degrees Fahrenheit, for a limited duration. The eruption of Tambora in 1815 had a significant impact on global temperatures, resulting in adverse effects on grain yields worldwide. This phenomenon may be contributed to the occurrence of famines in certain regions. These previous eruptions were very small in scale when juxtaposed with the potential magnitude of a supervolcano. And so, what is the probability of a super eruption occurring in Yellowstone? The level of something is extremely low. Indeed, there exists the possibility that Yellowstone may never have another volcanic eruption. Currently, there is no apparent indication of an imminent volcanic explosion. Yellowstone National Park experiences ongoing seismic activity, characterized by periodic earthquakes and fluctuations in ground elevation. However, these phenomena are considered within the realm of normal occurrences. According to the United States Geological Survey, Yellowstone National Park is exhibiting patterns consistent with its behavior during the previous 140 years. There is a strong likelihood that Yellowstone will remain free from volcanic eruptions in the forthcoming millennia. According to the United States Geological Survey, it is worth mentioning that the probability of a Yellowstone eruption occurring in a given year, based only on the analysis of the 3 most recent eruptions, is estimated to be 0.00014%. This probability is comparatively smaller than the likelihood of a catastrophic asteroid impact leading to the destruction of civilization. However, it should be noted that this estimate may not be considered reliable due to the lack of certainty on the regularity of Yellowstone's eruption cycle or the notion that it is currently overdue for another eruption. Indeed, the possibility of a substantial volcanic eruption occurring in Yellowstone in the future remains uncertain. Will super eruptions occur in Yellowstone in the future? According to Lowenstern, there is uncertainty about this matter. Yellowstone National Park has already experienced a significant and extensive lifespan. There is a possibility that a 4th eruption may not occur. Volcanoes ultimately undergo cessation. The magma chamber underneath Yellowstone is subject to the influence of 2 contrasting factors: the upward flow of heat originating from below and the comparatively lower temperatures present above the surface. If there is a decrease in heat transfer from the lower region, it is conceivable that the chamber may undergo freezing, ultimately resulting in its transformation into a solid mass of granite. It is noteworthy to mention that the volcanic hotspot beneath Yellowstone is undergoing a gradual migration towards the northeast. More precisely, the North American tectonic plate situated above the hotspot is undergoing a southwestward migration. The volcanic hotspot is gradually shifting in a northeasterly direction. Over an extended time frame, the hotspot will gradually shift away from its current position under Yellowstone, potentially resulting in the eventual cessation of volcanic activity within the Yellowstone supervolcano. It is conceivable that a further supervolcano may potentially manifest in the northeastern region. However, the underlying hotspot would need to undergo a process of thermal intensification and subsequent melting of the frigid crust prior to such an occurrence. The duration of this process has the potential to extend for a period of 1 million years or more. According to Lowenstern, comprehending a time span of 1 million years poses a significant challenge. The human species is quite recent in its emergence. However, the Earth has existed for an extensive duration, and the processes involved in these systems require a significant amount of time to accomplish their respective tasks. What is the size of the magma chamber located beneath the Yellowstone region? Yellowstone National Park is characterized by the presence of 2 subterranean magma reservoirs. The shallower layer is comprised of rhyolite, a rock type with high silica content. It extends from a depth of 5 kilometers to around 17 kilometers beneath the Earth's surface, spanning a length of roughly 90 kilometers and a width of approximately 40 kilometers. The chamber has a predominantly solid composition, characterized by a melt content ranging from approximately 5% to 15%. The underlying reservoir consists primarily of basalt, a rock type characterized by its low silica content. This reservoir is situated at a depth ranging from 20 to 50 kilometers, 12 to 30 miles, below the Earth's surface. Despite the substantial discrepancy in size between the deeper chamber, which is approximately 4.5 times larger than the shallow chamber, it is noteworthy that the former merely accommodates a mere 2% of melt. The methodology employed by scientists to ascertain this information bears resemblance to the medical technique of computed tomography (CT) scans, which utilize X-rays to generate 3-dimensional images of interior tissue within the human body. Similarly, seismic tomography is a technique that utilizes numerous earthquakes captured by multiple stations to quantify the velocity of seismic waves within the Earth. This data enables geophysicists to construct 3-dimensional visual representations of subsurface structures. Researchers conduct comparisons of seismic velocities and make inferences about composition by comparing them to baseline values that have not been thermally altered. Can we drill into Yellowstone to stop it from erupting? Limited scientific drilling can be beneficial in enhancing our comprehension of magmatic and hydrothermal systems. But it is important to note that drilling aimed at mitigating volcanic hazards presents a distinct topic with uncertain outcomes, substantial financial implications, and significant environmental ramifications. Besides the significant cost and technological challenges associated with drilling through the hot and viscous rock, it is improbable that drilling would substantially impact the underlying magma reservoir beneath Yellowstone. Under conditions of elevated temperatures and pressures resembling those found near magmatic sources, it is observed that any void or opening would promptly undergo closure due to the crystallization of minerals derived from the naturally occurring fluids present at such profound depths. In addition, the geothermal resource development is prohibited within the boundaries of Yellowstone National Park. The renowned geological attractions, including as the Old Faithful Geyser and Grand Prismatic Spring, rely on the thermal energy derived from the subterranean magma chamber situated beneath the surface of Yellowstone. The implementation of geothermal extraction, if permitted, would result in a reduction of pressure exerted on the current geysers and hot springs, thus modifying their characteristics and, in numerous instances, leading to their eventual disappearance. The concerns about volcanic eruptions at Yellowstone mostly revolve around the potential occurrence of a catastrophic event leading to the formation of a caldera. However, the likelihood of a future eruption of this nature remains uncertain. The present seismic imaging of the magma reservoir indicates that the system possesses a crystalline structure that prevents the occurrence of large-scale volcanic eruptions. In the event that there exists a substantial reservoir of magma with the potential for eruption under Yellowstone, engaging in drilling activities with the intention of alleviating pressure might result in severe and catastrophic consequences. Numerous scientific studies have consistently demonstrated that the process of depressurization has a significant role in facilitating the ascent of magma towards the Earth's surface, ultimately leading to volcanic eruptions. Efforts to cool and depressurize magma systems would yield numerous inadvertent and adverse outcomes, notably heightening the probability of an eruption. The implementation of a large-scale magma quenching program is not anticipated to occur at Yellowstone or any other location in the foreseeable future. Currently, Yellowstone National Park remains in a dormant state, while scientists diligently monitor its subtle fluctuations and disturbances in order to anticipate its future behavior. Although the geological activity under Yellowstone National Park has been suppressed for a considerable span of time, the current state of quiescence should not be interpreted as a permanent condition, since there remains the potential for future reactivation. The question still persists: at what point in time, and with what magnitude? Anderson asserts that we are entering a phase characterized by an anticipated increase in instability. However, he expresses skepticism and does not possess high expectations for this development. As Jermaine Greer says, perhaps catastrophe is the natural human environment, and even though we spend a good deal of energy trying to get away from it, we are programmed for survival amid catastrophe. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.